Welcome to Pindar Poetry. We hope you learned something new.
You start by gathering parts and mounting the sensor where it sees the rotating target. This gives repeatable pulses. Once fitted, connect the sensor output to a digital input on the Arduino and share the ground with the 5V supply. You should place the target at a consistent radius so each pulse represents one revolution. This prevents false readings. Also wire a pull-down or use internal pull-up on the input because clean logic transitions matter for accurate timing. Next, focus on extracting a reliable pulse and measuring time. Noisy signals ruin RPM readings. Use a simple RC filter or software debounce to ignore spurious edges because mechanical vibration can produce false triggers. Then capture timestamps with a hardware timer or micros on each validated edge and compute period between pulses. Once done, convert period to RPM using 60 divided by period in seconds. And for smoother results, average several intervals so transient jitter is reduced. Finally, calibrate and present the RPM clearly so you trust the meter. Compare readings to a known tachometer and adjust for any sensor offset. Then output the value to serial or an OLED and apply a small moving average to smooth sudden steps. This maintains responsiveness and readability. If readings jump or drop at certain speeds, make sure the sensor alignment and wiring are solid, increase debounce time, and verify the target marking is distinct. These fixes resolve most issues.
Thanks for watching. Consider subscribing if we helped you.